Hey there, Mr. Weaver here, and this is topic 2 and 3, lesson 7, slope-intercept form from graphs. After this lesson, you need to be able to identify the rate of change and the y-intercept from a graph, and you need to be able to write the equation of a line in slope-intercept form from a graph. After this lesson, you'll know you're successful if you can identify the rate of change and y-intercept from a graph, and then write the equation of the line that is shown in the graph. First, let's look at a couple features of graphs. So the two things that we're going to need to figure out in order to determine what equation is shown in the graph are the y-intercept and our slope. So the y-intercept is the value when x equals 0. If you remember back to previous lessons, it's when we have an input of 0. In a graph, it is shown as the coordinate 0 and then whatever the y value is. That is your y-intercept. And it's also where the line crosses the y-axis. Below we have 4 different types of graphs. So the y-intercept is where it crosses the y-axis. So that dot right there, that is 5 up, is our y-intercept. So the y-intercept in this case would be plus 5. In the second one, that horizontal line crosses at 3 up. If you look closely, it's halfway between 2 and 4. So our y-intercept there would be 3. In our third one, our y-axis is over where the arrow is. The line doesn't ever cross that situation. It does not have a y-intercept. And in our last graph, we have another y-intercept of positive 5. So again, that's just where it crosses the y-axis. The slope, on the other hand, is describing how steep the line is. So to figure that out, and we'll talk about this more in upcoming slides, but slope is how much it changes vertically, so up and down, compared to how much it changes horizontally, left and right. The slope is your rate of change. Now, in these 4 pictures, all of them have different types of slopes. So if you can begin to relate what type of slope it is with what the picture looks like, it can help you check to make sure you're on the right track. If the line seems to be going up from left to right, it is a positive slope. If it's flat, there is 0 slope. If the line is straight up and down, it's vertical, it is an undefined slope. And it actually is not a function, because if you think about it, it has many points that are directly over another. We're not really going to focus on this type. And the last type is a negative slope. So going left to right, it is going down. Before we begin to look at figuring out equations from graphs, let's focus more on the slope. So in the graph on the right here, we have point T and point S. If I wanted to figure out the slope between those 2 points, there's a couple different ways we could do it. So first is the slope formula. This involves taking the differences between the coordinates. So if I look at the y values, which is our second coordinate, 3 and 9, and I wanted to find the difference, I would just subtract. So going from 3 to 9 is a change of 6. I could have found that out by subtracting. 9 minus 3 is 6. Next, in our x values, it went from 2 to 6, so 6 minus 2 is 4. Now we take those two numbers and write them as a ratio of our y change over our x change. So it would be 6 over 4. And we could reduce it and say it was 3 over 2, but we're going to leave it at this for right now. Part D says compare the ratio in part C to the ratio of rise over run. Well, rise over run means how much does it go up by how much does it go over. So in this case, how many spaces did we go up? If we count 1, 2, 3, 4, 5, 6, it went up 6 spaces, and it went over 1, 2, 3, 4. So the rise was 6, the run was 4. Notice they are the same thing. Both of these methods work for finding your slope. If you're someone who just wants to subtract, go for it. If you're someone who wants to count how many spaces you moved, go for it. They're going to get you the same answer. Our slope formula then we can describe as either rise over run or our change in y over our change in x. And the second one, our slope formula, you are going to see it written like this, where it is y2 minus y1 over x2 minus x1. All that means is you took the second y coordinate and subtracted the first y coordinate, and then on the bottom you took the second x coordinate and subtracted the first x coordinate. Just subtraction like we saw on the previous slide. Within our slope-intercept form that we've been talking about, this slope formula is your m. So once you figure that out, you plug it in for m. And then that b value is just that dot we talked about right at the beginning with our y-intercept. Whatever the y value was when the line crossed the y-axis, we write that number as b. Let's go through a couple examples of finding the equation from our graph. First, let's find our y-intercept. So where is the line crossing our y-axis? It would be at that point right there. If we look at where it crossed down 5 at -5. So that is our y-intercept, -5. Now to find our slope, we need to figure out how much the line is changing up and down and divide that by how much it's changing to go over. So I need to pick another point that is on the line. So I'm going to choose that point right there. To figure out how my slope changed, I would need to go down 2 and over 5. Okay, again, we're counting the spaces, not the lines. So down 2 over 5, I would write it as a fraction of -2/5. Negative because it's going down. Had I wanted to use the slope formula, I could note that my blue dot is at 5, -7, and my pink dot is at 0, -5. Subtracting, I would get the same values, -2 over 5. Now that I have these things, I can plug them into my equation, and I'd end up with y equals -2/5 x minus 5. Now it's your turn. Pause the video and figure out the equation of the graph that is shown here. Let's check our answers. So our y-intercept was at -4. And then if we pick any other point on the line, so I can pick the next closest one, and I always work to the right. So I would have had to go down 2 over 1. So my equation would be y equals -2 over 1, x minus 4. Let's look at another example. First, I'm going to find my y-intercept. So this time it was at +2. Then to find my slope, I'm going to choose another point on the line. To go between the 2 points, I had to go up 3 and over 1. So my slope would be up 3 over 1. My y-intercept was plus 2. Plug those two things in. Y equals 3 over 1 x plus 2. In this example, and the one that you just did, we both have fractions over 1. We could just simplify those fractions to make it a whole number. So 3 divided by 1 is 3. In the one you just did, 2 divided by 1 is 2. So we could have said 2x. So here we end up with y equals 3x plus 2. Pause the video again and determine the equation for your line. Reduce the slope if you can. Check your answers. Your slope should have been 2/3. It went up 2 and over 3. You cannot reduce that. And our y-intercept was at positive 3. All of the examples that we've looked at so far have had positive y-intercepts, but if the y-intercept had been below the x-axis, so you had to go down to find it, we would end up with a negative y-intercept. Next example, find our y-intercept, figure out our slope. So my y-intercept is 0, my slope, it went up 2 over 4. Plug those in, I would end up with y equals 2 over 4x plus 0. When we have an equation like this, we can simplify our slope and we don't need to put plus 0. What that ends up becoming is just 1/2 x. So if you see an equation where there's no y-intercept, that just means it goes through the origin, through 0, 0. Conversely, if you see your line going through 0, 0, that would mean the y-intercept is 0, and you don't need to write it in your equation. Pause the video and try your example. You should have had y equals negative 1/4 x. Last example. If you come across horizontal lines, it looks a little bit different in the equation. Here's how it works. If I follow the same process and identify my y-intercept, so here it's at plus 4. When I'm figuring out the slope, again, just choose another point on the line. I'm going to choose one a little ways away. To go from one point to the other, I had to go up 0 and over 5. So 0 over 5. If I have 0 over anything, that means I have 0 slope. If you remember back to the earlier slide when we looked at the picture and it had a horizontal line, that was 0 slope because the slope is 0. When we're writing that, again, just like we had the y-intercept go through 0, we don't need to write 0. This becomes just y equals that number. And what this means is no matter what value of x we plug in, we get out 4. So our horizontal line is just y equals whatever the y-intercept is for the line. So pause the video, identify the equation for your line. Check your answer. Here we had a y-intercept below 0, so negative 2. The slope is 0, so y equals negative 2. In this lesson, we learned to write slope-intercept form from graphs. To do this, we need to determine the slope and our y-intercept. To figure out what the y-intercept is, we just look to see where it crosses the y-axis, and then whatever coordinate that is, use the y value as b in our equation. The slope takes a little bit more work, but you're just figuring out how much the line is going up and down, and then divide that by how much the line changes from left to right. So you'll commonly hear this as rise over run. and then simplify that fraction when possible. Once we know our slope and our y-intercept, we plug them into the equation, and we're all done. After this lesson, do you know how to identify the rate of change and y-intercept from a graph? And can you write an equation from a graph? If you're not sure about these things, go back and watch parts of the video to deepen your understanding. And that is the end of lesson 7 on writing an equation from a graph.